Okay, let's look at some specific example of how this works in practice. So first, in fraud detection. Fraud detection traditionally requires intense, labor-intensive analysis. So a fraud investigator might actually review suspicious transactions, interview customers, trace money flows, and so on, which is an incredibly time-consuming work. AI system can dramatically decrease this workload while simultaneously reducing fraud threats. So machine learning models can process millions of transactions in real time, learning patterns that indicate fraud through text mining, social network analysis, and pattern matching against databases of known fraud cases. What used to take weeks of investigation can now be flagged in milliseconds. Another example is data classification. So AI tools can automatically process and classify all available information according to predefined patterns and categories. A bank might have customer communications, transaction records, and third-party data all mixed together. So AI can classify this information by risk category, by data sensitivity, and by regulatory requirement. It can then monitor access to these data sets, flagging unusual access patterns that might indicate a data breach or insider threat. Finally, let's talk about threat analysis and management and risk reduction more broadly. So machine learning engines can analyze enormous amounts of data from various sources: internal transaction data, external market data, news feeds, regulatory announcements, whatever is available. This information then generates real-time prediction models that allow risk managers and security teams to address emerging threats quickly rather than discovering them after the fact. Think about cybersecurity risk, for example. A traditional approach might involve periodic audits and reviews, and by the time you discover a problem, it might have already been exploited. An AI-powered system continuously monitors network traffic, system logs, and user behavior, generating alerts and about suspicious patterns in real time. More generally, AI provides organizations with the ability to evaluate unstructured data about risky behavior or activities in their operations. For example, what does a rogue trader's email look like? What patterns in trading behavior indicate excessive risk-taking? What communication patterns suggest potential fraud? These are all hard questions to answer with traditional tools. But machine learning algorithms can identify patterns of behavior related to past incidents and then apply them as risk predictors for the future. So, in other words, the organization learns from its own history, both successes and failures, and applies those lessons automatically to new situations. So now I want to zoom out and think about the bigger strategic picture. How does AI create a competitive advantage for an organization? So here's a key insight. AI's real power in risk management emerges when you're dealing with unstructured data. Remember when I mentioned that traditional statistical models struggle with unstructured information? That's where AI competitive advantage really shines. So specifically, we're talking about cognitive technologies, advanced AI systems that can process and understand language, images, sentiment, and context the way humans do. The most important example is something called natural language processing, or NLP. So NLP uses sophisticated algorithms to analyze text data in order to derive insights and sentiment from unstructured information. Think about what this means practically. A bank receives thousands of customer complaints every day. These aren't in a neat spreadsheet. They're written complaints, emails, social media posts, call transcripts. A traditional approach might have someone manually read these and try to categorize them. But an NLP system can automatically read all of them, understand what customers are upset about, identify patterns, and then flag emerging risks. Maybe it discovers that 15% of complaints mention a particular product feature that's creating problems. Maybe it detects sentiment shifts that suggest reputational damage is building. Maybe it identifies potential fraud indicators in how customers describe suspicious transactions they've noticed. So here's then the competitive advantage. Leaders who leverage these cognitive technologies to anticipate and manage risk don't just reduce their losses, but they actually use risk as a strategic tool to power their organization's performance. They move faster than competitors. They respond to emerging threats before those threats become crises, and they identify opportunities where that others miss, and that is a powerful competitive advantage. So let's recap what we've covered and add some important details about AI's business value. First, the core benefit is that AI can improve both model efficiencies and accuracy. These aren't small improvements. We're talking about meaningful gains in predictive power and operational efficiency simultaneously. Second, as I mentioned earlier, companies around the globe are actively leveraging AI to ensure legal compliance and risk mitigation. This is not experimental anymore, it's business critical. Now I want to focus on one specific and powerful application: classification and better risk scoring. So let me use credit risk as our example because it's concrete and important. In credit risk, one of the most critical decisions any lender makes is, should I lend to this person? And if so, at what interest rate? This decision has historically relied on credit risk scoring models, and this is where AI is creating a revolution. So traditional risk scoring is becoming increasingly difficult and inefficient. Why? Essentially because of what we discussed earlier, the volume and complexity of available data. So organizations now have access to alternative data sources like utility payment history, rental payment history, mobile phone payment records, social media activity, behavioral data, and more. Traditional statistical model might use 5 or 10 variables. An AI system can process hundreds of variables. A traditional model might take months to incorporate a new data source. You have to do feature engineering and see how that feature is it actually predicting anything? Is it helping the model? An AI system can adapt quickly. You don't have to go through any of that. So, a credit scoring model then is fundamentally a mathematical model used to estimate the probability of default. Okay, and default here in this case has a specific meaning, which is the probability that the customer may trigger a credit event such as bankruptcy, an obligation default, failure to pay a loan, or what we call cross-default events, where defaulting on one loan triggers a default obligations on other loans. So more specifically, a credit risk score predicts the probability that a customer will become 90 days or greater past due on any given account over the next 24 months. Why 90 days? Because that's generally when a lender considers an account seriously delinquent and begins more aggressive collection efforts or write-off procedures. And the output is a 3-digit risk score. The score directly relates to that probability. Or as many professionals in the industry say, it relates to the probability of default, which we often call PD, probability of default. So let's use a concrete example to make this real. Imagine a consumer applies for a credit card. The bank runs this person's information through a credit scoring model. The model outputs a score of 750 out of 850. What does this mean? It means there's approximately a 0.21% chance this person will become 90 days or more past due on this account in the next 24 months. In other words, the odds are 2 out of 1,000 customers with risk profile will hit that delinquency threshold. Now, how do organizations build and validate these credit scoring models? Well, there's a variety of techniques they can use. Logistic regression, linear regression. These are traditional statistical foundational models. So these techniques have been used in credit scoring for many years. Machine learning and predictive analytics represent the new approach. So these algorithms can capture more complex relationships than traditional regression. Binning algorithms. So these help transform continuous variables into categorical ones, making them easier to interpret and more stable over time. Cumulative accuracy profile, or CAP, is a validation technique that shows how much better your model performs compared to random guessing. And ROC, or receiver operating characteristics, is another validation tool that helps you understand your model's trade-off between correctly identifying defaults and incorrectly flagging non-defaults. These techniques then work together. You might use machine learning to identify the most predictive variables, then apply binning to stabilize them, then validate everything using ROC. So by combining these techniques together, you can create a more robust and reliable model.